We're going to talk about simplifying monomials using our exponent rules. So first of all, if you don't remember what a monomial is one term made from a number or numbers, variable, or a product of both. So for example, just a number is a monomial. It's one term, it's a number. 5x is a monomial because it's made of a variable and a number, or the product of both. And then 5x squared is also a monomial. Now, we can have monomials that have multiple different variables, but the one thing we have to know, we'll see more examples, is that we do not ever want our final simplified answer or equivalent expression, or monomial in this case, to have a negative exponent or zero exponents. We want to simplify those. So let's look at our first example. 5y to the negative 3, x squared, and w to the fourth. So one of the strategies that's really good is to kind of split apart what your bases are. So we have a number here. We have a y there with an exponent negative 3, an x, and a w. Now, I'm going to think of this as our house kind of scenario, and I'm going to put this whole thing over 1. Kind of think about what can stay and what can go. So we're not doing any kind of powers. We're just simplifying them down right now. So 5 has a 1 exponent. He's perfectly happy. He's going to stay right on top in the top floor of the house. Y to the negative 3, however, is up here and it has a negative. We can't have a negative. There's nothing else to combine it with, so we're going to move y3 to the bottom, and when we do that, he becomes happy. He's now happy. So you ask yourself, can they stay or do they need to go? So x squared, positive 2, happy, he can stay. W to the negative 4, not happy, so he has to go to the bottom. Okay, so this would be our answer, our simplified. We don't have any negative exponents and we have no exponents of 0. All right, so let's look at this one. B, m to the negative 5, and v to the second. These are not like bases, so we can't use our quotient rule. But, so we're going to look individually. This starts out as a fraction, so we think, it might end as a fraction. May not, we'll see. So let's look at m. Oh, we have a negative. He's not happy up there, so let's move him to the bottom. And then v squared, well, they're happy, just fine right there, so they get to stay down there. So you think, what do we put on top? Well, we put a 1. Just think about it this way. We have a 1 here, and we have a 1 here. 1 divided by 1 is still 1. It's going to stay on top. So this would be our simplified answer. All right, let's move to a 3 star. So we're going to then think, oh, it might be a fraction, so we'll start there. If it doesn't end up as a fraction, we can just get rid of the fraction bar. All right, so let's look at individual. First of all, we have p, x, y, and m. So nothing can be combined or simplified down with like bases, so we're going to look at individually. We have p to the negative 4. Not happy. Move him to the bottom. We have x to the 3. Okay, he's fine. Keep him there. Now let's look on the bottom. We have y to the 5th. Perfectly happy where he is. We can leave him in the basement. M to the negative 2, not happy. They need to go upstairs. Okay, so now we have our simplified expression, or our simplified monomials here. Now, the next thing we need to know how to do is to evaluate, and we've done this before with multiple things. So one of the tricks I want to remind you of is to use parentheses, especially when you're dealing with negative numbers and exponents. So if they tell us that m is going to be 2 and t is going to be negative 3, when we plug this in, we're going to use parentheses. So m is going to be replaced by a 2. So we're going to use a parentheses, and then we put our negative 2 here. T is going to be replaced with a negative 3. So we're again going to use our parentheses and place our negative 2. Now we're going to go ahead and simplify. So when we think about negative exponents, we know that we want to change those to be not in the location that they currently are. We want to make them happy. So we're going to then look at each individual piece. Okay. Now we could have easily done this beforehand. And so I'm going to show you one way and then we'll show you the additional way. So we can think about 3 is happy where he is. 2 to the negative 2 is not happy. So we're going to put him on the bottom and he becomes positive 2. Negative 3 is our base. So that negative in front of 3 has nothing to do with it. But the negative 3 being raised to the power of negative 2 does have something to do with it. So we put him on the bottom. So I'm going to use parentheses here. And we have negative 3. Now he's positive 2. Okay? Now we can then simplify. Well, 3 is 3. 2 squared is 4. And a negative 3 squared is saying a negative 3 times a negative 3. Negative is positive. 3 times 3 is 9. So then we have 3 over 36. We can then simplify that down even further by dividing by 3. We get 1 over 12. And this would be our final answer. Now, if we didn't do this first, we could have went ahead and looked first and said, is he happy? Yes, he can stay on top. Is he happy? No, he can go to the bottom. Is he happy? No, he has to go to the bottom. So you can always think about this over just a 1 to begin with. And then you could have subbed in. So we would have had 3, and then 2 squared, and negative 3 squared. We would end up the same answer. So it's either way you wanted to do it. Just using parentheses is a big thing that's going to be helpful. All right, so let's go into some applications using all of our information that we've learned so far. So one of the things that you need to be careful about is making sure you don't forget a piece and you do them kind of systematically one at a time. So again, I like to kind of use my little pencil or colored pencils and separate what I have. Okay, so I'm not going to think about moving things happy or sad yet. I'm going to go ahead and I know that these are being multiplied. I'm going to deal with everything first. So first of all, I'm going to deal with my numbers. So I have a 4, a 2, and a 4. So I'm saying 4 times 2 times 4. Well, 4 times 2 is 8. 8 times 4, 32. So my numbers equal 32. Okay? So my numbers are finished. Now let's look at my m's. So I have a like base of an M, and an M. So what I have here is an M, and I have a 3 plus a 5 plus a negative 6. So when I put all those together, I have 3 plus 5 is 8. 8 plus a negative 6 is 2. So I have M to the 2. So the M's are taken care of. Now I'm going to look at my P's. I have a P, and a P. So I have a P as a base. I have a negative 2 plus a 6 plus a negative 5. Now, when I look at that, I say negative 2 plus 6 gives me a 4. 4 plus a negative 5 actually gets me a P to the negative 1. Now I want to see, I've combined all my terms together. I want to see how things are happy or sad. So 32, is he happy upstairs? Yes, he can stay upstairs. Is M squared happy? Yes, he can stay upstairs. Is P to the negative 1 happy? No, he moves to the bottom. So this would be our final answer. All right, let's go to the second example, B. So notice we have now some powers raised to a power. And this kind of pulls in some other rules, product of product powers, that we didn't specifically talk about, but we want to talk about each piece. So what I would do before I move further and start combining things is I'm going to simplify each section of this first. So remember, this is being applied to every piece here. And there's a 1 there, whether we see it or not. So this is 2 is our base. 1 times negative 5 is negative 5. A is our base. 2 times negative 5 is negative 10. And C is our base. 4 times negative 5 is negative 20. All right, so that has been simplified with my power to power rule. Now I'm going to simplify this one. So I have every piece. So I have C to the negative 6 and A to the 42. Now I can start looking and see, what do I have? Now I'm not going to simplify this to the negative 5 yet. I'm just going to write them down because I don't see any other numbers over here. So I'm thinking about my numbers, my A and my C and my C and my A. So I'm just going to keep him as a negative 5 for now. And then I'm going to look at my like bases, A and A. So these are being multiplied, so that multiplication rule is adding. So I keep my A, and negative 10 plus 42 gives me 32. Then I have my C, so I keep that base, a negative 20 plus a negative 6. So it's like adding those two together. I have a negative 26. Now let's see if we're happy or sad. So I always think about putting it just over a 1. And is 2 to the negative 5 happy? No. So he goes to the bottom. Is A to the 32 happy? Yes. Is C to the negative 26 happy? No. Put him to the bottom, and now he becomes positive. Now, the only thing left that we need to do is to actually simplify 2 to the 5th power. We don't know what A value is or C value, but we do know that we can evaluate 2 to the 5th power. So A to the 32 stays, C to the 26 stays where we put him, and 2 to the 5th power is actually 32. So this would be our final answer. All right, so let's look at C. So C is a 10 star, and it can be pretty complex, so we're going to do it step by step. So again, we're going to just simplify each piece first. So we're going to just ignore the stuff in the little box over there, and we're going to simplify each piece. So remember, power to power has to affect everything. This is a 1 here. So don't try to do, go ahead and calculate here, just step by step. So 2 to the 3rd power, A to the 12th power, and B to the 9th power. We'll put it back in parentheses because we're multiplying here. We don't want to think about we're adding or just putting them together. All right, so let's do this little piece here. Now notice this negative 2 is in parentheses, so we've got to remember that when we simplify. Negative 2 to the 3rd power, because we're applying it here, and B to the 3rd power. And then this is all being raised to the 2nd. So now that it's being raised, we can go ahead and simplify that. So 2 times and times. Okay, so negative 2 is still our base. I'm still going to keep it in parentheses. And 2 times 3 is 6. Okay, and then B, 3 times 2 is 6. Now, what we have here, we'll rewrite this bottom one, or the first one, and we're going to multiply. Do not try to combine this 2 and this negative 2. They are not the same basis, okay? One's a negative 2 and one's a positive 2, not the same. So we cannot combine those bases. So we can go ahead and evaluate 2 to the 3rd power. We know that's 8. And I'm going to rewrite everything else. And then a negative 2 to the 6th power. Remember, if it's in parentheses, the whole thing's being raised to a negative. So that's saying negative times a negative times a negative times a negative times a negative. 1, 2, 3, 4, 5, and 6. So if it's an even number, we know it's going to come out as a positive. So 2 to the 6th power is actually 64. Okay, and then we have B to the 6th. So now we've simplified our numbers in each piece. Now we're going to look at each individually, multiplying them together. So look at our numbers, 8 and 64. 8 times 64 is 512. Then we have a base of A. Don't have a base of A over here, so we just rewrite A to the 12th. But I have a base of B and a base of B, so they're being product multiplied together. So we add 9 and 6, and we get B to the 15th. So this would be our final answer. Whew, that's a toughie. All right, so now let's move to where we see some division. So these are some of my favorite ones, and this is where your little colored pencils or your separating pieces will really work well. So I'm going to go ahead first, and I'm going to separate my numbers. Oh, I have some M's, like bases, some N's, and Y's. And if they're never written, if you ever get one that's not written correctly on top of each other, just rearrange them. As long as you don't move them somewhere else, you can rearrange them because it's being multiplied. So it doesn't matter if you rearrange them. So now we're going to look at just our numbers. So a negative 9 divided by a 27 gives us a negative, and we know that we can simplify that to 1/3. So that takes care of our numbers. Now we have an M base. And when we're simplifying, we're going to put him upstairs first. He may end up going downstairs because he may end up negative, but we're going to start with him upstairs. So 3 minus, remember that fraction line's a minus, a negative 2. So you have 3 minus a negative 2, which is the same thing as saying plus, so it's M to the 5th. Then we have an N, 5 minus 7, so we have N to the negative 2. And now we have Y to the 0. So we're just going to put our y here. We have 0 minus, remember this is a minus, a negative 4. So 0 minus a negative 4 is actually a plus 4. So we're going to put that as a 4. Now, let's ask if things are happy or sad. This negative in front of a number does not make it flip. Only a negative exponent. So this stays a whole negative, and we can put it out front or we can put it up with a 1, either way. So that 1/3 is staying just the way it is. M to the 5th is fine. N to the negative 2, not happy. So he moves to the bottom. Y to the 4th stays on top. So here is our final answer. All right, let's go to example B. This is a 3-star. So notice we have some things inside. I put parentheses around these to help you. You will not always see them with parentheses inside. So if we had something that was here, let's say, we would take care of that first and then do all that's inside the parentheses before we would apply this outside exponent. So let's try this one. So we're going to go ahead and look inside. So our numbers, our C's, and our D's. So 3/5 can't be reduced any, so we're going to keep it as 3/5. C is our base. We have a negative 2, so we have the negative 2 minus 8, so we have a negative 10. D is our base. There's a 1 there. 1 minus 4 gives us a negative 3. So now we've simplified down what's inside here, and we're going to raise it to the negative 3. Now, this gets applied to every piece, not just the numerator, but also the denominator. So this gets applied here, here, and here, and well as here. Okay, remember this is a negative. So this is a 3 to the negative 3. C, a negative 10 times a negative 3 is 30. D, a negative 3 and a negative 3 is a positive 9. And then 5 to the negative 3. All right, so now we got to ask if things can stay or go. So this one's a little bit different because our C's, our variables, and our D, they have positive, very happy exponents, so they get to stay on top. However, our numbers are not, and they're not like bases, so we can't combine them. 3 and 5 are not alike. Even though the exponents are the same, 3 and 5 are not alike. So 3 to the negative 3 actually is going to go to the bottom. 5 to the negative 3 is going to go upstairs. C to the 30 and D to the 9th get to stay right where they are. Now we would need to simplify further. 5 to the 3rd power is 125. C 30 and D 9 get to stay, and 3 to the 3rd power is 27. Now, if these numbers could be reduced down further, in either by fraction form or by just to an integer, then you would do so.